Welcome to part B of the chapter on e-business, in which we will discuss online payment, business-to-business technologies, as well as supply chain management. Here you can see the overview of the chapter once more. So we kick off with online payment, then proceed on to B2B technologies, and conclude with supply chain management. Let's kick off with online payment. There are various ways to do online payment. The most popular is undoubtedly using credit or debit cards. These support instant payments, come with fraud protection mechanisms. In fact, I did some research myself on using artificial intelligence to detect fraudulent credit card transactions. And in case a fraudulent transaction took place with your credit card, you can ask for a chargeback. In other words, you can ask to get your money back from the fraudulent transaction. Another means to do online payments is by using bank transfers, in which case the payments are made directly from the customer's bank account, typically by scanning a QR code. These can be done manual in case the customer initiates the transfer, or automatic in case the merchant pulls funds from your account, obviously with your permission. In Europe, this is facilitated by means of the SEPA, or Single Euro Payments Area Initiative, which facilitates bank transfers, which makes them fast, secure, provides them at low cost, standardizes them, and facilitates cross-border payments within Europe. Another means to do online payment is by using digital wallets. Here, users store payment information securely and can pay with a simple click or scan. Popular examples are PayPal, Apple Pay, Google Pay, and Samsung Pay. This often also includes features like loyalty points or cryptocurrency storage. Another way is the BNPL method, which stands for Buy Now, Pay Later. In this case, and this is typically for larger purchases, or this is a method that is often adopted by younger people that often lack money. In this case, customers will split the payments into installments or delay the full payment until a particular date in the future. This is often also integrated directly at checkout in order to provide a seamless shopping experience. You will often see at checkout that there's like a platform like Klarna, which allows you to implement this buy now, pay later online payment method. Another way is by mobile carrier billing. So in this case, the charges are added directly to the customer's mobile phone bill. This is often used for digital goods like apps that you purchase in the App Store, subscriptions, and so on. Cryptocurrency is another way to do online payment. Popular examples of cryptocurrency, the most popular example is undoubtedly Bitcoin, but there are others as well like Bitcoin Cash, Ethereum, Dogecoin, Solana, etc. And in fact, there are different types of payment. Let's first zoom out a bit. Cash is a way of doing payment, which is what we refer to as peer-to-peer. So I have my cash and I purchase something from you and I give my cash directly to you. So there's no intermediate person or institution. With a wire transfer, the bank acts as an intermediate because it's my bank account that is going to transfer money to your bank account using the bank as an intermediate. Digital money is a digital platform that acts as an intermediate because the buyer has a PayPal account and PayPal will then transfer the money to the receiver. In case of cryptocurrency, we also have a peer-to-peer payment mechanism. And the idea of cryptocurrencies is to develop what we call a blockchain. We will explain that in a few moments into more detail. And a blockchain is in essence a distributed ledger of all transactions visible and available to everyone. So everyone that operates on the blockchain can see who paid who, how many bitcoins were transferred, when, etc. So it's a public ledger that is available and visible to everyone. Everyone can see ingoing, outgoing transactions on the entire blockchain. They can see all of them. Bitcoin was in fact an initiative that was created by A person or a consortium, we don't actually know who it is, but it's a person or a consortium, unknown, but under the name of Satoshi Nakamoto in 2009 when he, she, or them wrote the first paper and when blockchain and Bitcoin was initially launched. So here you can see how it works. Let's start in the upper left corner where we have Bitcoin transactions. So here you have various sellers that accept Bitcoin as a payment medium. Think about Starbucks, think about Adidas, think about Microsoft, think about Amazon, etc. So the sellers accept Bitcoin as a payment means, and buyers have a wallet of Bitcoins that they can use to actually pay and buy products or services from Starbucks, from Adidas, from Microsoft, and Amazon. So here we see that transactions are taking place and which are being paid with Bitcoins. Once a sufficient amount of transactions has been obtained, a block is being formed and the transactions are represented as a block which contains a block header, and later on we're going to discuss more about this block header, and various types of transactions. So transaction one could be Bart buys a coffee at Starbucks. Transaction two could be Emma buys some shoes at Adidas. Transaction three could be Sophie buys a product on Amazon. So these are all transactions. They're represented as a block. And then to the right here, we have Bitcoin miners that take the block and solve a mathematical puzzle. So they have to solve a mathematical puzzle or riddle. And once they successfully did that, it means that they validated the block, and the block can be added to the public ledger that we refer to as the blockchain. And once the Bitcoin miners successfully validated or solved the block, they will take the next block. So the Bitcoin miners, they're typically big companies, we will come back to them later on. They take one block at a time, they solve the mathematical puzzle, and then add the block to the blockchain. As such, the blockchain provides us with a public ledger because it's accessible to everybody participating in that blockchain system. Everybody can go back as far as they want until the Genesis block. The Genesis block is the first block that was ever mined, that was ever validated back in 2009 when Bitcoin and blockchain was launched. So we have a sequence of blocks that are connected to one another in a particular way. I will explain that in a moment, and that have all been validated by Bitcoin miners. And the blockchain, once more, is the public ledger. What companies are accepting Bitcoin as a way of payment? There's many of them: Starbucks, Microsoft, AT&T, Adidas, Amazon, Air Baltic, Home Depot. Tesla used to accept Bitcoin as a payment means, but they then switched to Dogecoin, right? As this obviously comes as no surprise. Now, what is a Bitcoin miner? A Bitcoin miner is a person, but most likely it will be a company. It can be an individual or a company that uses big computational power, so a very powerful hardware server, to solve the complex mathematical problem that basically validates the block. So it's validating one block at a time by, for each block, solving a very complex mathematical puzzle. And why does a Bitcoin miner wants to do this? Obviously, a Bitcoin miner wants to do this because he or she earns a reward with it. And what is the reward? The reward is Bitcoin, a few Bitcoins or part of a few Bitcoins, as we will see later. So the reward is expressed in Bitcoin plus transaction. That's a transaction fee. That's a percentage of the transactions which are part of the block that is validated and verified by the Bitcoin miner. So that's their incentive. Their incentive is that they're being paid in terms of Bitcoins and a percentage of the transactions, in other words, the transaction fee. These Bitcoin miners are usually big firms that consume quite a lot of energy. We'll come back to that later. Located in the United States, China, Russia, or Kazakhstan. There we see the biggest Bitcoin miner firms operating. Let's elaborate a bit further and give a few numbers. What's the average number of transactions in a block? It depends on the network activity, on how much is happening on the network. And obviously, it also depends upon the size of the individual transactions. But on average, for Bitcoin, it's about 2,500 transactions per block. For Ethereum, which is another very popular cryptocurrency, it's a lot less. It's about 190. So let's elaborate a bit further, and let's first introduce the idea of a hashing function. A hashing function plays a very critical role within this whole blockchain ecosystem. A hashing function is a mathematical function that takes an input of any size and produces a fixed size output. So it's just a mathematical function, fx, which gives you y. That's what it does. Bitcoin uses SHA-256, which stands for Secure Hashing Algorithm 256 bit. In other words, the output of the hashing function that is being used by Bitcoin is always 256 bits. So it's 1011 and 256 of those. 256 ones or zeros next to one another. So the output of this hashing algorithm is always fixed in size, 256 bits, whatever the size of the input. A hashing function, in fact, has different properties. It's deterministic, so that means that the same input always gives the same output. It can be computed very fast. That's another property. And another property, which is very interesting, is that a small change in the input can drastically change the output. So it's very sensitive to the input, right? A small change in the input can cause a big change in the output. Also, it is extremely unlikely to find two different inputs that produce the same output, that produce the same hash. The hash is the output. So it's extremely unlikely to have two different inputs that produce the same output, or in other words, the same hash. That's what we refer to as collision resistance. Another property, and that I already mentioned, is the property of the fixed size output. So no matter how large the input, the output always has the same length. These are the core ideas of hashing functions. Now let's have a little bit more of a deep dive into the block contents. The block, which has a block header and all the transactions together with some other information. The block header, first of all, has a link to the previous block, in the blockchain, so it will link to the previous block hash. The block hash, which is the cryptographic hash of the block header that serves as the block's unique ID, as mentioned at the bottom of my slide. So if at the bottom of my slide, you see that within a block, we have the block header, we have all the transactions, the block size in bytes, and then the block hash. The block hash serves as an identifier of the block. So it's the block hash, let's first go to the bottom bullet, is the cryptographic hash of the block header that serves as the block's unique identifier. The block header then has a reference to the previous block hash in the blockchain, so it links to the previous or prior block in the blockchain. It has a Merkle root, it's a complex term, but it's a single hash that summarizes all the transactions within the block. A single hash, so ones and zeros, 256 of those, that summarizes all the transactions in the block. It has a timestamp to indicate when the block was mined, when the block was validated. It has a nonce. The nonce is a number that can be used only once. We will come back to it in a moment. The nonce is, in essence, is the solution to the mathematical puzzle that was found by the Bitcoin miners. Then it has a difficulty target, which is the proof of work requirement. We're going to come back to that later on. After the block header, we have all the transactions. Then we have an indication of the block size in bytes. And then we have the block hash, which is the idea of the block. In other words, it's a hash of the block header that serves as the block's unique identifier. That's the block content. So now let's get into a little bit more detail into the mathematical puzzle or mathematical riddle that needs to be solved by the Bitcoin miners. The Bitcoin miners are all looking for the nonce. The nonce is the number that can be used only once. It's the solution to the mathematical puzzle. And how does it work? The idea of Bitcoin mining is to find a nonce here, that's a number, such that if you take x, x is the block header data, and you apply the hashing function, so the 256-bit hashing function I referred to earlier on. If we apply the hash to the block header plus the nonce, it should be less than a cutoff C, than a difficulty target C, which is typically put as a constant, right? So the Bitcoin miners need to find the nonce, the number that can be used only once, such that if they apply the hash to the nonce plus the block header data, it's less than a difficulty threshold, right? If it turns out that the Bitcoin miners take quite a lot of time to find that nonce, so if it's very difficult to solve the mathematical puzzle or solve the mathematical riddle, what the blockchain will do is it will actually increase C a bit to make the mathematical puzzle a little bit more easier, such that the Bitcoin miners will more quickly and more easy find a solution. So C is like a dynamically adjusted difficulty constant that can be increased in case it takes the Bitcoin miners too long to find the nonce. Now, all of this is based on hashing, and I told you that very small changes in the input in this case is x plus nonce, can cause very big changes in the output. So that means that hashing behaves very unpredictably. So that means that the only way to solve this mathematical puzzle is trial and error. Try different types of nonces. So what all these Bitcoin miners will do is they try different types of nonces, apply the hash function. If the hash of x plus the nonce is less than C, they're happy, the mathematical puzzle has been solved, and they will get their reward in terms of Bitcoins and the percentage of the transactions or transaction fee. So what these Bitcoin miners essentially do is they will test millions or billions even of nonces until success. So this will require quite a lot of trials, quite a lot of computation, and quite a lot of ecological footprint, as we will come back to later on. In essence, this is what we refer to as proof of work, because the first Bitcoin miner that is able to find that nonce, such that the hash of x plus the nonce is less than C, is able to solve the problem. It will broadcast the solution. It will proudly say to the entire blockchain and Bitcoin environment, I solved the riddle, I found the nonce, and then as such, proving they did the work. So that's the concept of proof of work. The average time to mine a Bitcoin block is on average about 10 minutes. Once it starts getting bigger than 10 minutes, what the blockchain system will do is it will increase the C. It will put the C a bit bigger to make it easier to solve the mathematical puzzle. So C is dynamically adjusted to make sure that it doesn't take too long for the Bitcoin miners to find a solution to the problem. Note that the average time to mine this cryptocurrency block, in this case it's Bitcoin, is different for other types of cryptocurrencies because they're based upon other standards, protocols, and rules. The blockchain can then be stored on computers, nodes that participate in the Bitcoin network. So remember, the blockchain is the public ledger that is stored on computers, nodes that participate in the Bitcoin network. Each node will then keep a complete copy of the entire blockchain. Every block and every transaction since the very first block, which is what we call the Genesis block, and that was launched in 2009, is available on the entire blockchain. So the entire blockchain is in essence a distributed ledger. Everybody has access to the entire blockchain, can see all the blocks from the first block that was mined, the Genesis block, back in 2009, to the most recent block that was mined or validated. So in other words, this is a decentralized system and is replicated across thousands of machines, thousands of computers, nodes that participate in the Bitcoin network. Everybody can verify the history. Everyone that participates in the system can see all the blocks with all the transactions, as such providing data integrity, but as such also providing security against fraud, against tampering, against maliciously adjusting some of the transactions. That means that we also do not have a single point of failure because the entire blockchain is stored on computers that participate in the Bitcoin network. The most popular and most important implementation of the blockchain is Bitcoin Core, which you can see right here. Bitcoin Core. You can see Bitcoin Core. You can download it if you want to participate in the blockchain network for various types of operating systems. You can follow up on some of the releases. You can look at some of the development. Even you can contribute if you want. Obviously, if you contribute to the Bitcoin Core, all of this needs to be properly validated. So this is, in essence, an open source project which maintains and releases the Bitcoin client software called Bitcoin Core. It also refers to the Bitcoin white paper. Here you can see of Satoshi Nakamoto that was published in 2009, remember, and it has both full node software for fully validating the blockchain, as well as also has facilities for setting up a Bitcoin wallet, which is something that I will refer to later on. Okay. Good. What is the maximum number of Bitcoins? Well, the maximum number of Bitcoins has been capped to 21 million. We haven't reached that yet, but it will be reached somewhere around 2140, so far in the future. The reason why it's capped, I'm going to come back to in a moment. Remember that for mining Bitcoins, for mining blocks, actually, for mining blocks with transactions, rewards are being given. So the reward for mining these blocks drops by 50% after approximately every 210,000 blocks are being validated or mined. So that's approximately every 4 years that the reward is halved. So that's what we call the halving mechanism. The reward for mining new blocks is halved after every 210,000 blocks are mined, which takes place on average every 4 years. Historically, what we often witnessed afterwards is that the Bitcoin price increases significantly after halving. Now, why is there a maximum number of Bitcoins in the system? And why do we have this halving mechanism? Well, the idea is to control the supply and to prevent inflation. Because if a resource is limited, it makes it robust against inflation. Same goes with gold. Gold in the long term is very robust with respect to inflation. Why? Because there's only a limited availability of gold in the world, just like there's a limited availability of 21 million Bitcoins. If you take one gold coin, it depends a bit on how much gold is in there, on whether it's 99% carat or 95. But like the average Bitcoin, the average gold coin right now is about, I'll have to look it up because gold is increasing a lot, but it's about 600 euros. So one gold coin, small gold coin, is about 600 euros right now. Now, let's take a step back in time. It's a long step back in time. If you read some old Roman literature, or if you're fascinated by history like I am, in the time during the Roman period, if the Romans wanted to buy some kind of fancy clothing, what we call a toga, it costs them one gold coin. If nowadays I want to buy a decent suit, then it costs me about one gold coin as well, 600 euros. For 600 euros, I have a decent suit. So in other words, the point I want to make is that one coin of gold maintained its value because I could have used it during the Roman period to buy one decent suit back then, which is what we call the Roman toga. And I can also use it now to buy a decent suit. So it kind of maintained its value. So if people say that gold increases in value, Often that's a bit of a dubious statement because it's not gold increasing its value, it's gold maintaining its value. It's money that is decreasing in value. So if you see that a gold coin now is worth 600 euros and it used to be worth 500 euros like back a year ago or something, it's just implying that money, or the euro in this case, loses value. Gold is something that is pretty resistant with respect to inflation. And the same we see right here with Bitcoins, because we have this 21 million cap on the Bitcoin and this halving mechanism. So as such, Bitcoin is very robust with respect to inflation. We have a secure value over time, and the halving mechanism also incentivizes early adopters because they are rewarded more generously. Over time, you will see that because of this halving, the Bitcoin miners will get less and less Bitcoins, so they will rely more and more transaction fees. Once the maximum number of Bitcoins has been reached, that will be around 2,140, then obviously Bitcoin miners will no longer be rewarded in Bitcoins, but they will be rewarded in terms of a percentage of the transaction as a transaction fee. Here you can see this highlighted. So you can see the Bitcoin supply. This is this line right here. And you can see the inflation rate. The inflation rate, this is the source where I got this from, is the inflation is the new Bitcoins mined in a year divided by the Bitcoins in circulation at the start of the year. And here you can see that going down, right? Here you can see that this graph ranges until 2041. So in 2041, we still haven't reached the 21 million yet. As I told you, we will reach the 21 million. We're close to it in 2041. But because of this halving, the reward becomes smaller and smaller, so there are less Bitcoin circulating in the system. But the maximum 21 million will be reached not in 2041, but in 2140. That's the dynamics. Okay. Then we have the concept of a Bitcoin wallet, where Bitcoins are being stored and where they can be used for making purchases, for doing trading, etc. So a Bitcoin wallet holds the Bitcoins, and this can again be implemented using Bitcoin Core, using the website I just showed you. A Bitcoin wallet has a couple of things. It has a private key. That's like your password, your secret number, your password. You don't reveal it to anyone. It's used to sign transactions. It's used to sign transactions in Bitcoin. Your public key is derived mathematically from your private key. So it's a mathematical transformation of your private key. It can be shared. It can be used by others to verify your signatures. And it will also act as a cryptographic proof that a transaction was signed by the private key. From the private key, we can derive the address. The address is a shorter, user-friendly version of the public key, or a hash of it, so a hash transformation of your public key. And it's what you're going to give to people to receive Bitcoins. If I want to receive Bitcoins from you, I just give you my address. So it acts pretty much like an account number. If I want to do a wire transfer, or if I want money from you, either I give you my account number or either you give me your account number. So the account number is pretty similar to the address. Private key, password, public key derived from private key to verify your signatures, and address, which acts as your account number. So how does a Bitcoin wallet work? I create a Bitcoin wallet, right? I can again do this in Bitcoin, in the Bitcoin Core system, as I mentioned. Create a Bitcoin wallet. That will generate a private key. I keep this confidential to myself. From the private key, a public key can be derived, and then the address can be derived. It doesn't go the other way around, obviously, right? Because that would break the security. If based upon the address, someone could derive the public key, and based upon the public key, someone could derive the private key, it would break the security. So it only goes one way. We share the address to receive Bitcoins, and when spending Bitcoins, we use the private key to sign the transaction. The network will then use the public key to verify the signature validity. Okay, are there other cryptocurrencies? Yes, there are other cryptocurrencies. And remember, Bitcoin worked along the principle of proof of work. That means that Bitcoin miners had to solve a mathematical puzzle. They had to find the nonce. Ethereum first also worked using the principle of proof of work. So it worked along the same way. The classical version of Ethereum worked along the idea of proof of work, where Bitcoin miners had to solve that mathematical riddle. But since 2022, Ethereum, which is another cryptocurrency, changed from proof of work to proof of stake. So the validators in this new Ethereum version launched from 2022 onwards, the validators don't solve mathematical puzzles. So the validators actually provide crypto amounts, such as a few Ethereum coins, as the collateral, as the stake. So a couple of things are worth noting. Here we talk about validators. We don't talk about miners. Miners are actually solving mathematical puzzles or riddles. This was the case for Bitcoin. Here in Ethereum, from 2022 onwards, Ethereum adopted proof of stake, where the validators provide a certain amount of crypto as the collateral. This is the stake. In other words, they have skin in the game. The validators have skin in the game, right? They provide collateral, the stake, in order to validate Ethereum blocks. Based on the stake size, based on how much collateral the validators have provided, and based on some randomness, the Ethereum blockchain network will randomly select a validator to propose a new block, which is composed with transactions, every 12 seconds. So every 12 seconds, a validator is selected to propose a new block. So a block is a gathering, a collection of transactions. And other validators need then to attest the validity of the proposed block. Attesting the validity of the proposed block means that they have to verify the block to see whether the signatures are okay, to see whether there's no double spending. Double spending means that the same Ethereum coin is spent twice. That could be part of a fraudulent mechanism, for example. So the other validators need to verify for every block whether it's correct, are the signatures correct, are the transactions correct, is there double spending? If there's double spending, that's not correct, that should not be the case. And if the block is correct, they can vote for it. They can vote for the validity of the proposed block. And in case the vote is successful, the Ethereum block will be added to the Ethereum blockchain. This is proof of stake, so this is not solving a mathematical puzzle. This is just providing crypto as collateral. In other words, the validators have skin in the game. If the validators behave honestly, they need to be incentivized, right? They need to be incentivized to behave honestly, so they will earn rewards, just like in Bitcoin, the miners earned Bitcoins if they successfully solved the mathematical puzzle. Here, if the validators behave honestly, they earn rewards or Ethereum coins. If they cheat, if they propose or attest invalid blocks with invalid signature, or if they participate in fraudulent schemes such as double spending, where one Ethereum coin, which is in essence a digital code, is spent a few times as part of a malicious scheme, then they lose part of their collateral. They lose part of their stake. Depending upon the severity of the fraud, they can lose the entire stake or part of it. So they lose the entire collateral, they lose all the Ethereum coins that they put at stake or part of it, depending upon the severity of the fraud in which they have been engaged. That's what we call slashing. Slashing means that they lose part of their stake, they lose part of the collateral that they provided. So the key idea here is that the security comes from economic incentives. The security does not come from Bitcoin miners that solve a mathematical puzzle, but comes from economic incentives. The validators have skin in the game. They provide crypto amount as collateral. And if they do their work nicely, correctly, do not engage in fraudulent practices, there will be no slashing and they will be rewarded. Obviously, because no complex mathematical puzzles need to be solved, this is far more energy efficient and eco-friendly because no sophisticated hardware is needed that is consuming quite a lot of energy resources, as we will see in what follows. So let's have a look at this ecological impact. Proof of work, which is the Bitcoin system, that consumes quite a lot of energy, right? It's estimated between 100 and 150 terawatt hours annually. Right? It's similar energy consumption to entire countries like Argentina or the Netherlands just to keep this system up and running. That's quite a heavy ecological footprint. Bitcoin mining generates about 65 to 100 million metric tons of CO2 emission annually. Substantial. Also, there's significant electronic waste because we have powerful hardware to do all this mining. But obviously, hardware is subject to continuous improvements. So once the old hardware has become outdated and can no longer do the mining sufficiently because it's not powerful enough anymore, it needs to be thrown away and it becomes part of electronic waste, which is another heavy ecological footprint. For Ethereum, that works along the proof of stake mechanism, the energy use is significantly reduced, even by 99.9%. Here you can see a website provided by Cambridge, I think it was, Cambridge Bitcoin Electricity Consumption Index, where Bitcoin and Ethereum are being contrasted. Here you can see the annualized consumption. Here you can see 181 terawatt hours. This is for Bitcoin, and this is updated every 24 hours, depending upon how much activity is taking place on the Bitcoin network. So try to remember that number, because now I can look for Ethereum. That was terawatt hours. This is gigawatt hours. It's a lot less, right? So Ethereum, because it works along that proof of stake mechanism, is a lot more eco-friendly than Bitcoin. And you can play a bit, you can do some comparisons right here if you want. So I would definitely advise you to browse that website a bit. Okay, so let's zoom into the next part of this chapter, which focuses on B2B technologies, business to business technologies. We're going to talk about EDI, XML, CXML, application programming interfaces, APIs, web services such as SOAP and REST, RosettaNet and EBXML, and then also we'll see a reoccurrence of this blockchain mechanism, but within the context of B2B platforms. EDI stands for Electronic Data Interchange. It's an old protocol for exchanging documents between computers that typically belong to different parties, to buyers and sellers that communicate electronically by means of EDI. It's old. It's what we refer to as legacy technology. Should we still discuss it then? Now yet? Yes, definitely, because many of modern day companies are still using EDI as a way to electronically interchange or exchange data. There's various EDI implementations. There's ANSI X12, which is the American National Standard, which was launched by the American National Standards Institution. And there's EDIFACT, that was an EDI implementation initiated by the United Nations. The idea of EDI is to transfer data from one firm to another in a commonly agreed format, because if we have a common vocabulary, it will facilitate the unambiguous exchange of information like purchase orders, like receipt documents, like a request for quotes, like invoices, and so on. Because it's standardized, it can be processed by the receiver system without human intervention. Because EDI is a standardized data definition follows a data or is implemented using a standardized data definition vocabulary, it can be processed by the receiver system without human intervention. So that allows us to establish long-term, point-to-point, firm-to-firm, organization-to-organization, and tightly coupled relationships. Right? Its legacy, I told you, it was introduced already quite a few years ago, but it's still widely used in business-to-business integration practice. And many large firms have deeply embedded EDI systems that have been running reliably for already decades. Decades because, as I told you, it was introduced a long time ago. So you can see Toyota, for example. Here you can see some information about the Toyota EDI and how Toyota, a car manufacturer, uses EDI for integration. So you get your system, this is the system of Toyota, and all the information that is passed along and that relates to shipment, that relates to product, that relates to inventory, that relates to orders, invoices, or accounting, it's all standardized using EDI. Same goes for DHL. All the information that is being passed along to DHL can be standardized. If partners want to collaborate with DHL, it can be standardized by using the DHL standard EDI messaging service. So it kind of standardizes all the messages that need to be sent between your business and DHL Freight, DHL Global Forwarding, and DHL Express. Here you can see it's highlighted once more. So I have computer systems of two different partners that collaborate together, a buyer and a seller. This is the buyer, this is the seller. The buyer is going to send EDI purchase orders to the seller. It's going to send EDI payments to the seller. The seller is going to send EDI shipping notices to the buyer. It's going to send EDI price updates to the buyer and EDI invoices to the buyer. And that means that all these companies receive these EDI messages, and they will translate them internally using their internal computer systems to information that they can understand internally. So let's say that company A has some kind of ERP system, enterprise resource and planning system. We will refer to that as ERP system A. Company B has another ERP system. Maybe company A has ERP system from Apple. Company B has an ERP system from Oracle, let's say. So this is ERP system B. So the way company A and company B then collaborate is by means of EDI. So EDI will be used to actually translate all information from company A's EDI system, which was an SAP system, to company B's EDI system, which was an Oracle ERP system. Middleware is translation software. That means that it translates SAP to EDI in company A. And if company B receives an EDI message, it will be translated using middleware, which is translation software, to its Oracle ERP system. So let's say that company A sends a purchase order to company B. Then the purchase order is first created in SAP. This is then, by using middleware, translated to EDI. The EDI purchase order is sent to company B. Company B receives the purchase order in EDI, and it will use middleware to translate this EDI message to its Oracle ERP system. That's how it works. So the middleware is translation software. Here you can see an example of an EDIFACT invoice. EDIFACT, remember, was the implementation of EDI as it was put forward by the United Nations. So here you can see in blue, you can see the EDI message. And after the hashes, here you can see a hash symbol. You can see the meaning of the message. So this is just a comment that indicates what this means. So in blue, we have the EDI fact invoice information. So it has all kinds of codes in there, codes that we call delimiter. DTM is like a delimiter. I remember this is a date delimiter. So here, this is the date delimiter that has the document date. So the delimiter is DTM plus, and then here we have the document date, which is the 17th of June 2025, which is when I'm recording this, by the way. Here you can see another delimiter, BGM plus. You can look up what these delimiter means, what these delimiters mean, but here it refers to the invoice number. So this is invoice 001 right here, and an original indicator as well. Various types of delimiters. Here another date, which is the delivery date, the purchase order number. So here we can have a delimiter, RFF plus, and this is followed by the purchase order, PO12345. The buyer code, we have the buyer with the code and the name. So the buyer is Sport World, and the supplier is Best Shoes. So here this is an invoice for tennis shoes, I think it was, or a pair of shoes, right? So here you can see the currency of the invoice. You see the product. You see the item, running shoes. It was running shoes. You can see the item description. It was running shoes, two pairs of running shoes, and so on. So you can see all the information by means of the EDIFACT delimiters, and then followed by the information. So this is standardized, right? So everybody that uses EDI or EDIFACT in this particular case can understand this invoice and can process it internally in their information systems using the middleware I referred to earlier on. Benefits of EDI interchange are speed of transaction, so we can very quickly do that. We can very quickly start from SAP, generate a purchase order in EDI, send it to company B. Company B is going to get this EDI purchase order using middleware. It will automatically be translated into its Oracle ERP system, and the transaction goes very fast. So we have reduced transaction costs as well, less errors because everything is standardized, because an EDI purchase order is standardized, an EDI invoice is standardized, so all the information is directly on there, right? So because it's standardized, there's less errors, so we can also do more just in time, right? So there's bigger just in time activity that can take place, which will translate into lower inventory costs and obviously result into a significant competitive advantage. So it's an advantage for supplier and customer, but it does depend a bit on the balance of the power, because there's some disadvantages as well. Because if I'm a small company and I would like to do business with a big company, let's say I'm a small company, I'm into making special or importing special types of tea, for example, and I want to sell that to a supermarket, a big supermarket. So I'm a very small company selling tea, and I want to sell my tea to a supermarket. And the supermarket says, yes, we can do that. We are interested in engaging into a partnership, but we want to collaborate through EDI. So I'm a small company. That means I have to invest into EDI. That means I have to accommodate my information systems to support EDI. Let's say I do that, and I start collaborating with this huge supermarket and selling my tea by means of EDI. That means by investing in EDI, I establish a long-term point-to-point, my company to the supermarket, and tightly coupled relationship, which is good, but which can also create weaknesses. Because I'm a small company, that means that I have to make a high initial investment in my IT infrastructure to make sure that purchase orders, whatever, that invoices, all of this takes place by means of EDI. So I have to adjust my IT infrastructure. I have to make a big initial investment in my IT infrastructure. This is also, this creates a high risk of what we refer to as vendor lock-in. Vendor lock-in means that since I'm a small company, I become too tightly coupled to that big supermarket. So if the supermarket at a particular moment in time says, yes, we are still interested in your tea, but we want to have a price promotion. We want to have a price reduction of 5%. Being a small company selling tea and having made this huge investment in my IT infrastructure to support EDI, I'm in a weak position because I made that big investment and I become too tightly coupled to the supermarket. So if the supermarket says we want a price reduction of 5%, it's going to make me think, right? Do I really want to support this? Yes or no? Because I made such a huge investment in my IT infrastructure, I'm kind of too much coupled, too much connected. That's what we call vendor lock-in. That's the risk of EDI vendor lock-in in case the small company becomes too dependent upon a bigger player. So that's why sometimes EDI is not very attractive for SMEs, because there's a high initial investment that has to be made to adjust all the IT systems, and that comes with the risk of EDI vendor lock-in. EDI, you've seen the syntax on the previous EDIFACT example. It's not very programmer or web friendly, right? So it's like very complex syntax, and it's less suitable for networked or collaborative environment. It's less suitable to work in a networked or collaborative environment. So that's why it's an old technology, and nowadays we see many companies shifting away from using private communication networks that were often implemented by means of EDI towards using internet-based standards, internet-based technologies of collaborating. And one of them, which is very popular, is XML. XML stands for Extensible Markup Language, which focuses on the content. So it's a meta markup language, which in contrast to EDI, where the delimiters, the code words, or the tags have been predefined and were fixed, in XML, we can define the tags, the delimiters, the code words, or selves for a particular domain or purpose. And we define that typically using a document type definition, DDT, or XML scheme. There are two ways to define the layout, the content of a purchase order, the content of an invoice, the content of a shipping note, a shipping document, the content of a delivery notice, and so on. So DDT and XML scheme are two ways to formally define an agreed tag set and structure for a collection of XML documents like purchase orders, shipping notices, invoices, and so on. And as such, it can serve as a very user-friendly way of exchanging data between B2B applications, because now we can exchange XML tags for catalogs, we can exchange price lists, purchase orders, invoices, inventory reports, bill of materials, all nicely and neatly represented in XML. Here you can see that same invoice that I used previously to illustrate Edifact. Here you can see that being represented in XML. So here you can see that the tags are a lot more easy to interpret. It's a lot more user and programmer friendly. We can see the invoice. We can see an invoice which has a header which has an invoice number, the date, the delivery date, the purchase order, and the currency. Then we have the parties and so on. So here you can see various tags that are nested. So invoice number is an XML tag nested within header, and that contain all the information. Obviously, we have to agree on this definition of this XML document up front. A definition of an XML document is provided using a document type definition or XML scheme. So using a document type definition or an XML scheme, it will tell us that an invoice should consist of a header, of the parties, of the line items, and a summary. That a header should consist of an invoice number, an invoice date, a delivery date, a purchase order, and a currency. All of this is specified as part of a document type definition or an XML scheme. This focuses on the content. If we want to represent it, then we can represent it in HTML. Here you can see how this previous XML document, this focuses on the content, can be represented. Typically, this is done using an extensible style sheet, XSL, but we're not going to comment on that any further, into HTML. This is HTML representing the same invoice in a web browser. So here you can see the header being represented in a table, parties in a table, the line items in a table, and the summary as well. So here you can see HTML represents the information of the XML document, right? So we started from Edifact, focusing on the on Edifact, focusing on the content, but not very user-friendly. Then moved on to XML, which is a lot more user-friendly and understandable, and HTML gives us the representation. Here you can see that XML can be used to process documents automatically, because now the purchase orders are represented in XML, shipping notices are represented in XML, invoices are represented in XML, and now we can use generic tools to support XML document transformation and processing. So now it's the XML documents that have to be translated into the internal ERP systems of Company One. Company One, for example, using the SAP ERP system, and Company 2 using the Oracle SAP system. But now, since XML is some kind of very universal standard, it's very straightforward to process XML documents in Oracle as well as in SAP. There's a particular variant of XML which is called Commerce XML, CXML. This is a standardized XML-based protocol, particularly designed for B2B transactions. So it's a particular document type definition. The document type definition of CXML specifies the structure, all the various elements, attributes, and relations in a CXML document, like a CXML purchase order, a CXML invoice, and so on. So it actually specifies the exact tags that should be used, how they should be nested, what attributes the tags have, and so on. All of this is specified in the CXML document type definition, which enables, obviously, the automated exchange of procurement information, requests for quotes, purchase orders, invoices, shipping notices between companies. This has been widely used in supply chain and e-procurement systems to integrate buyers, suppliers, and to have them collaborate with marketplaces. Here you can see that same invoice again being represented in CXML. So CXML is a particular version of XML that corresponds to the CXML document type definition and specifies a unique set of tags like header, from, credential domain, how they should be defined, how they should be nested, and so on. So here we can see that invoice being standardized according to the CXML standard. The most popular standard when compared to EDI, XML, CXML that is being used nowadays is JSON. JSON stands for JavaScript Object Notation. It's very user-friendly. It's lightweight. That means it doesn't have a lot of syntax rules. It's a data interchange format, just like EDI, just like XML, that is easy for humans to read and write. I'm going to show you an example of a moment, and very easy for software or machines to parse, to process, and to generate. Right? An SAP system, like an ERP system like SAP or Oracle, can very easily generate JSON documents and parse them. That means read them and understand what's in them and process them. JSON is going to represent data as key value pairs, arrays, which is a series of elements, and nested objects. So it's very similar to how data is structured in programming languages such as Java, such as Python, Perl, etc. It's very widely used in web APIs. We're going to come back to that in a moment. Very frequently used in cloud services and e-business platforms to exchange information. Most of the information exchanged nowadays happens by means of JSON. It supports native data types like numbers, strings, booleans, arrays, and objects without requiring additional type declarations. So supporting these data types is something that differentiates JSON from XML, because in XML, everything is text-based. So it's very lightweight, and as such, it enables real-time, lightweight data exchange, which makes it ideal for the mobile applications for web and microservices architectures. Here you can see the JSON representation, again, of our invoice. So you can see it's very readable, it's very easy, it's very user-friendly. It's very accessible to us humans, but also to programs. Here you can see that text is always represented between quotes, but as opposed to XML, it also allows to represent numbers as actual numbers. Let's have a look. Here you can see quantity is represented as an actual number, 2. 2 is not between quotes, so we know it's a number. Line amount is not between quotes, so we know it's a number. And the same goes for total amount and amount due. Here you can see JSON and XML contrasted. So JSON has simple key value pairs. It supports arrays. Arrays are series of objects, nested objects, whereas XML is a lot more verbose. It's a lot more verbose. In terms of readability, JSON is more compact, human, and program friendly, human and program readable. It supports strings JSON, numbers, booleans, and arrays, whereas in XML, everything is text-based. JSON documents are defined using a JSON scheme, right? Whereas XML documents are defined using an XML scheme. which is XSD, or a document type definition, DDT. JSON is very popular. It's being used in APIs, web services for B2B interaction. XML is also used, but it's less popular nowadays than JSON. JSON is a lot faster and lighter. XML is typically has more overhead due to the tags and the structure. JSON is a little bit less extensible because it has more of a fixed structure compared to XML, which is a bit more extensible via attributes and mixed content. Okay, we have already referred to APIs quite a bit. So what is an API? An API stands for an application programming interface. So many firms nowadays, like eBay, like Amazon, like Instagram, they will expose some functionality by means of an API. That means that Instagram will allow developers to access Instagram services by means of an API, by means of a function call. So an API is often a function call to send requests to Instagram, to send requests to Amazon, to send requests to eBay, and to maybe get something in return, to ask for information from Instagram, to ask for information from Amazon, from eBay, and so on. So an API allows us to communicate with another party like Instagram by sending it a particular function call. We're going to see an example of that in a moment. So an API in essence is a set of rules and protocols that allow different software applications, so my website, my app, for example, to communicate and exchange data either in XML or JSON with Instagram, with eBay, with Amazon, etc. That's what an API does. So if I have like a website and let's say that I'm very passionate about Italian cooking, right? So I start up my own website, my blog post, my blog website that has various information about Italian cooking, but I also want to connect with Instagram and see whether there's some interesting posts on Instagram that relate to Italian cooking. And I want to have these posts occur on my website or in my app. The way I could realize that is by calling the Instagram API. I can call the Instagram API and see, hey, Instagram, are there any recent messages that relate to Italian cooking, that have a hashtag Italian cooking, that have a hashtag pasta or pizza and so on? And that, if Instagram says yes, it can send those messages along and I can post it on my website. That's one way of collaborating with Instagram through its API. I can communicate with Instagram. If I want to communicate with eBay, I can, from my application, for example, I can post certain types of products for auction on eBay through the API. I can say, look, on my website or in my app, I have a certain type of product. I can click on a button and it's going to send the product straight to eBay where it can be posted on the website as part of an auction. All of this happens through the API. So the APIs allow different websites, different apps to communicate with one another. Obviously, Instagram, eBay, and Amazon will decide themselves what functionality they are willing to offer through their API. So Instagram has an API that tells other people, look, if you want to use our API, this is what we can offer to you, such that you can use it for actually retrieving certain types of messages, retrieving certain types of information, or posting something directly on Instagram from your app, from within your app, from within your website, etc. So APIs can connect systems, it can connect apps, my website to Instagram, to eBay, to Amazon. So that gives us possibilities to have e-stores with payment gateways, to PayPal, shipping services, or inventory management. It enables automation because now I can communicate with eBay through the API. So it allows me to update stock levels automatically, process payments securely, and actually what APIs do is it facilitates integration with partners, right? Because every partner in the digital world will typically expose the functionality that it provides to the outside world by means of an API. Instagram has an API, eBay has an API, Amazon has an API, and then we can see what they provide through their API and see how we can embed that into our app, into our website, and so on. So there's payment APIs. If I develop an app and I want to actually make sure that people can pay with PayPal, I just make use of the PayPal API. I'm going to make use of the PayPal API in my app, in my website, to allow for secure payment processing in my app. Shipping APIs, so DHL or FedEx provide shipping APIs to automate label generation and track updates. So if within my app, I want to ship something through FedEx, I can make use of the FedEx API. Here you can see the ship API from FedEx, which allows to process and submit shipping requests to produce a shipping label or return label in case of a product return, and cancel shipments before they are offered or tendered to FedEx. So if I have in my app, I allow people to configure a product, and the product needs to be shipped, and I choose FedEx as my shipping provider, I can actually, through the API, make an API call to FedEx, ask the API for a shipping label, and attach that to my product, and then use FedEx for shipping. So the ship API allows me from within my app or website to directly produce a shipping label that can be used to follow up on the shipping. Social media APIs allow me from within my app to connect through to social media channels. So for example, I can make use of the Instagram API to allow users from within my app to log in with their Instagram credentials. Obviously, users will do that only when they want to. But by logging in with their Instagram credentials and by importing their Instagram information into my app, I can do all kinds of things with that. I can better customize the user experience based upon the Instagram information that users have imported in my app or in my website. So the Instagram API, here you can see it actually has two APIs, and note that it's still referring to the Facebook page right here because Instagram is part of Meta, Meta has Facebook, Instagram, and WhatsApp. So here we have an Instagram basic API and we have an Instagram graph API, which is a bit more advanced, but Instagram basic API enables my app to let you as a user import your media from Instagram into my app, connect your Instagram profiles, and do various things on my app, staying connected with your Instagram profile. So I, as the owner of the app, can then make use of all kinds of Instagram information that you are willing to import, and I can offer all kinds of facilities to better tailor the user experience based upon the Instagram information you provided me with. And I can also allow you, for example, to, after having interacted or done certain things in my app, to post that back to Instagram. So through the Instagram API, I'm actually communicating from within my app with your Instagram account. You import your Instagram account into my app, give me all the information, I tailor my app based upon the Instagram information to your needs, and I'll also allow you, whenever you decide, to post certain types of product or service experiences back to your Instagram app from within the app that I developed. The Instagram Graph API is a little bit more business oriented and allows businesses and creators to manage presence on Instagram from your app. So it's a little bit more advanced, as you can see here. eBay Marketplace APIs, these are Amazon or eBay APIs. They enable to talk to, from within my app, from within my website, to talk to Amazon or eBay so as to sync product listings, stock, and orders. From within my app, I can decide that the product should be put for auction, for example, on eBay by means of the eBay API, because I integrate my app together with eBay by using the eBay API. Obviously, APIs are also extensively used in customer relationship management and ERP integrations, where APIs will help to link e-business platforms with the CRM or ERP systems. Here you can see an example of an API call, right? So here you can see this is a piece of HTML code, right, to represent information. This is right here a script. This is a JavaScript, so don't worry about the code too much. What's very important is that I make an API call right here. You can see in green, I make an API call because on my website, I want to calculate the exchange rate of US dollar to euro. So I make an API call to an API service provider, exchangerate.api.com, and that has an API that allows me to call it using the fetch JavaScript method. that gives me a response. The response will then be formatted as JSON, and that's the response right here that we will see. So this is the JSON representation that represents the response. So we have the base currency, which is USD, the date when the request was made, and then the rates of $1 in euro, in British pound, and so on. So the API sends through the browser, it sends a request by means of the fetch. The API returns the data in JSON, as you can see it right here. The JavaScript will then read and extract what we need, because what we need is the exchange rate of $1 in euro. This is this piece of code, what it's doing right here. And then the page content will be updated dynamically. Errors are handled if needed. So that's how it works. That's how we can call APIs. And in fact, these APIs are used a lot in web services, because web services are services that are provided across the internet. For example, a weather web service allows applications to retrieve weather data for a specific location via HTTP request. It allows me to know, for example, what is the weather nowadays in London at this very moment. That can be provided by means of a web service. Software designed to support interoperable interaction over the internet, typically by means of the hypertext transfer protocol, HTTP, which is a standard protocol for operating on the internet. Web services will expose functions or data that other applications can use by means of APIs, and the format for data exchange is typically XML or even more frequently JSON. And there exist two protocols for implementing web services APIs. They are REST and SOAP. REST is the most popular. REST stands for representational state transfer. So it allows me to call an API using HTTP and exchange data, typically using JSON or XML. So here you can see I use GET to ask for the weather right now in the city of London using this API, right? So using this API. It's very simple and easy to implement. REST is the most popular protocol for web APIs nowadays because it's so easy to implement. But for the sake of completeness, it's important that you also know the simple object access protocol, abbreviated as SOAP, which is another protocol for building APIs that is a lot stricter and XML based, and it's a lot more complex. So is it used? Yes, but it is not as popular as REST because everything needs to be defined using exact message formats based upon XML schemas. Both REST and SOAP are often used for web services, but as I mentioned, REST is the most popular because it is so simple. Okay, so let's look at B2B process integration framework, because much of the discussion right now has focused on exchanging data in standardized formats. So we exchange data using EDI, EDIFACT, XML, CXML, JSON, and so on. But what about the steps of the process? Because every purchase process has a step, right? It has a step like request for quote, provide quote, request for purchase order, ship the products or approve purchase order first, then ship the product, send invoice, payment, and so on. So you have different steps within a purchase process, of which not only the data should be automated and standardized, but of which also the steps of that process should be ideally standardized. So the idea of B2B process integration frameworks is to standardize the exchange of information between companies through agreed process definitions. So now we're focusing on the process, message formats, and communication protocols. So we standardize the business process steps. Who does what, and what's the sequence of the various steps? So we're focusing on things like message choreography or sequence, like first there should be a request, then a response, then a confirmation, and there should be some exception handling in case problems have occurred. So we also need to clearly specify the different partner roles, interactions, timing, dependencies, acknowledgements, and errors. So it's not only about the what, the data structure for which we can use XML, EDI, or JSON, but it's predominantly about the process flow, about the how. This is what B2B process integration frameworks will focus on. And there's various types of standards that are very popular here. Rosetta Net is the first one. Very important. Rosetta Net provides predefined, detailed business process specifications targeted towards electronics, semiconductor, and high-tech sectors. Read that very carefully. It provides predefined, detailed business process definitions or specifications. This is as opposed to EBXML, which is more generic and cross-industry, and it's a framework. So it's a framework that allows you to define business processes. RosettaNet has defined detailed business processes. EBXML goes one step further and provides a B2B framework that allows you to define and implement business processes, message structures, and data repositories for any sector. So again, the difference, RosettaNet provides the predefined business processes. EBML has a framework, provides a framework that allows you to define these business processes. Swift is a particular protocol standard targeted towards banking and financial services in a sense that it provides standardized message formats, not only message formats, but also process models for financial transactions, such as payments, security settlements, trade finance, all obviously across a heavily secured global network. Good. So here are examples. Sony, for example, uses RosettaNet processes to automate procurement, inventory management, logistics transactions with its suppliers, contract manufacturers, and distributors. You can think of a government agency that could define and publish EBML XML business processes, which have been defined using the EBXML framework, remember, for supplier bidding, for contract awards, and for invoicing. Any modern day global bank will use Swift message standards to automate cross-border payments, trade, finance operations, and security settlement across its network of correspondent banks. So Swift is actually a very well-known and well-respected standard in the financial services industry. Okay, so now we've already seen blockchain within the context of cryptocurrencies, within the context of Bitcoins and Ethereum. But we can also see the blockchain as a generic concept, so not based upon any cryptocurrency, but for setting up B2B collaborations or B2B platforms. So in this case, we have a B2B digital platform, which will use the blockchain technology, so blocks with transactions that are connected, to enable, track, and secure transactions, data sharing, or interactions between companies. So now this is based upon a blockchain, which provides a distributed ledger that is accessible to everybody participating in that B2B platform. So it will record transactions in a secure, transparent, and fraud or tamper-proof way. And it will as such provide a single source of the truth that all participants of the B2B platform can trust. So there's no need for intermediaries. It's just a set of B2B partners that jointly agree to set up a blockchain, often not based upon cryptocurrency. It can be based upon classical digital currencies. And often one needs to ask for permission to participate in the blockchain. Often this is a private or permissioned blockchain, which is only accessible to a few consortium partners that jointly agree to set up that blockchain and that jointly agree to set up that public ledger. So participants need to be typically pre-approved. They need to go through a vetting or screening process in order to participate in the blockchain and need to be and are capable of validating transactions. Blockchain-based B2B platforms can be further automated using smart contracts. What is a smart contract? Well, a smart contract is like a program that is self-executing. It's stored on the blockchain, and it automatically enforces rules and execute actions whenever conditions are met. And obviously, these smart contracts have to be approved by all partners that participate in the blockchain. Smart contracts are immutable. That means that they cannot be changed. They are being put on the blockchain. They're visible, transparent to everyone on the blockchain. Once they're being on there, they cannot be changed. They're visible, transparent to everyone on the blockchain. They're a way of collaborating. They actually represent a set of rules that have been mutually agreed by all B2B partners on the blockchain, as such representing a set of rules. That allows us to reduce disputes and manual intervention. Here you can see some examples of business rules that can be implemented using a smart contract. An example of a business rule that can be implemented using a smart contract is if the buyer confirms delivery, then there's automatically a release of the payment to the seller. If the shipment arrives at the port and customs clearance is confirmed, then the goods can be released to the buyer and the shipping company can be paid. So all of this can be implemented as smart contracts, made available, transparent on the blockchain, and are immutable. That means no one can change it because it's part of an agreement between all the partners on the blockchain. Okay, that brings us to the final part of this chapter, which is supply chain management, right? The final part of this part B of this chapter is supply chain management. Supply chain is how we're going to monitor goods throughout the entire supply chain, from point of origin to point of consumption, in the most optimal way. So it relates to the coordination of production, inventory, location, transportation, and information among all participants in a supply chain to achieve the best mix of responsiveness and efficiency within a particular market. Traditionally, supply chains were very linear. So we had a customer, we had the retailer, we had a distributor, we had a manufacturer. Think about Nike, for example, and we had various tier 1, tier 2, tier 3, tier X suppliers providing us with all the source materials. So a traditional linear supply chain obviously has an upstream side and a downstream side right there, right? So traditionally in the physical world, in the offline world, that was very linear. Because of the online world, we see lots of collaborative networks, virtual companies, where this whole supply chain is obviously virtualized and where we have lots of plug and play partners. Right, so we have a whole collaborative network, retailers, distributors, logistics providers, manufacturers that are highly loosely coupled. That means if we want to switch logistics provider, we want to change from FedEx to UPS, it can be done very smoothly and very easily within a collaborative network or a virtual company, thanks to the digital technologies such as the web. Now, in supply chain management, it's very important to be able to track the goods, to see where the goods are situated somewhere in the supply chain, to get real-time updates such that customers and businesses can see where goods are at any moment. And all of this can be implemented using various types of technologies. Barcodes and QR codes are obvious examples, but barcodes and QR codes need to be actively scanned. So a barcode needs to be scanned, QR code as well, using a scanning device. So the products and the packages will be labeled with barcodes or QR codes, which are scanned at key points. So using a scanning device as soon as they enter the warehouse or they exit the warehouse. And every scanning will result into a data update into the inventory systems. RFID tags, which stands for radio frequency identification, are small tags that can be attached to the goods or packages of goods, which have microchips in there that allow to do two-way communication, such that the good or the package that contains the good can say, hey, to an RFID receiver device, I'm situated right here in the warehouse. So these are tags with microchips that readers can automatically read such that they can detect the products without line of sight scanning, without needing a scanning device, which enables a lot more faster and bulk tracking of the items, of the products, or of packages. So this is very common in warehouses in retail. Obviously, when the packages are underway in cargo trucks, we can use other ways of tracking them using GPS and Internet of Things sensors, because modern day vehicles, containers are equipped with GPS trackers such that we can see where the products are on the way, where they are within the supply chain, because IoT sensors can monitor location, temperature, sometimes also humidity and shocks, which is very critical for fragile or perishable goods. So that provides us with real-time visibility across the supply chain. Blockchain can also be used, again, for secure and tamper-proof tracking of the goods to see where the goods are, so that every handoff can be recorded, for example, in the distributed ledger in the blockchain, as such, improving transparency as to where the goods or packages are located. What's really important in modern day supply chain management applications is the idea of the circular economy. The circular economy means that we're going to move away from the process of take, make, dispose, right? We're going to go away from this process towards emphasizing resource efficiency, try and reduce waste, and continual use and reuse of resources, such that we end up with the idea of the circular economy. In that respect, reverse logistics and product recovery becomes very essential because we need to design supply chains not only in one way, but backwards as well. We need to design supply chains to facilitate return of used products, components, make sure that we can repair them quite easily, maybe upgrade them, refurbish them a bit, remanufacturing, use them again in the manufacturing process of other products, or recycle them if needed. That's the whole idea of the circular economy and reverse logistics. The idea is to design for circularity such that the product design is done in such a way to ensure products are durable, easily to repair, easily disassembled, making it easier, obviously, to recover materials and components from used products, as such, facilitating the circular economy. A private industrial network is another idea within the context of B2B e-business, which brings together a small number of business partners, strategic business partners, to collaborate and develop highly efficient supply chains. So it's a closed collaborative platform with controlled access. That means that everybody that wants to gain access to the private industrial network needs to be screened, needs to be vetted. Focus here is on integration and efficiency, and that can be realized by permitting the partners to share product design, development information, marketing information, scheduling information, and inventory management. So it's a private set of partners that collaborate. An example of this is ExoStar, that is a private industrial network that securely connects aerospace, defense, and life sciences companies with their suppliers and partners. So before you can participate in that, you obviously need to be screened, you need to be vetted, you need to be evaluated before you can actually participate in that. So here you can see the various solutions that are provided. The industries it focuses on, as I mentioned, aerospace and defense, healthcare, life sciences, some computer services as well. So here you can see, for example, within aerospace and defense, it's a trusted collaboration for aerospace and defense. As such, since it's trusted, it means that it's a private industrial network because only a limited set of partners are allowed to participate in this BIN collaboration. Very important within a supply chain is the bullwhip effect. The bullwhip effect means that if we look at the supply chain, and here it's visualized like a linear supply chain, but obviously it can also be a non-linear or ad hoc supply chain. It means here you can see that here this is the customer demand for products. And as you can see, it's very volatile. Usually it's based upon forecasts as they have been generated by AI models. But in order to serve the customer, the retailer needs to make sure that it has a sufficient amount of inventory. So it's going to actually introduce some excess inventory to make sure that it can accommodate customer demand at all times. Likewise, the distributor needs to be able to accommodate the demands from the retailer. And actually what you see is that small demand fluctuations at consumer level will cause larger and larger variations upstream the supply chain, right? So that's what we call a bullwhip effect. So it's like hitting a bullwhip, right? Because if you have a bullwhip, you have a small, and you hit it, you have a small fluctuation at the beginning that becomes bigger and bigger as you travel upwards the supply chain. This is the result from delays, overreactions to backlogs, forecast updates which are not accurate, not always accurate, order batching, which all leads to excess inventories or stockouts as you progress further up the supply chain. So this obviously is not a desirable effect as it increases costs, reduces service levels, and make supply chain planning less efficient. So we can counter this bullwhip effect by a technology which we call vendor managed inventory. Vendor managed inventory means that all of these partners will open up their inventories for upstream partners. So what if the retailer would open up its inventory to the distributor and give the distributor direct access to its inventory systems? Likewise, the distributor can decide to give the manufacturer direct access to its inventory systems. The manufacturer can then decide to give the supplier direct access to its inventory systems. So that way we connect all the inventory systems a lot better, bring them a lot more closer, and we realize the idea of what we refer to as. So in that way, as I was saying, we realize the idea of vendor managed inventory, where a company is managing inventory levels of downstream value chain partners based on forecast demand and prior agreements on minimum and maximum stock levels. This could be part of a service level agreement, for example. This has various benefits. From the seller side, it allows us to optimize production planning and overall supply chain efficiency, which is going to counter the bullwhip effect. From the buyer side, it allows to relinquish control in return for cost savings. So the end result will be a more competitive end consumer price. This concludes part B of this chapter on e-business, in which we discussed online payment, B2B technologies, and supply chain management.